In question 1, first question, we're asked to find A so that the above defined function is a valid joint density function. So basically, if we integrate this function in terms of both x and y, we should get 1, which is the cumulative probability. So what we can do here is to integrate this, and then eventually we'll get 1 over a times 4 equals 1. So we have a equals 4. Second question, are x and y uncorrelated? We can know this by calculating the expectation of random variable xy, random variable x, and random variable y. So if expectation of xy equals expectation of x times expectation of y, then we can prove that x and y are uncorrelated. To get the expectation of xy, we simply move the random variable xy into the integral and then multiply with the density function, with the joint density function, and we have 1 over 9 for the expectation of variable xy. And then we can find e of x is 0. So we can know that this equation is not true. So we can know that x and y are not uncorrelated. The third question, are x and y independent? If x and y are independent, then x and y are uncorrelated, so x and y can't be independent. The fourth problem, find the joint density function of x squared and y squared. And so we can let z equals x squared and w equals y squared. And we can get the roots. There are actually four roots. Positive, negative square root of z, positive, negative square root of w. And then for each pair of roots, we can get the Jacobian matrix, the Jacobian determinant, and then we have 1 over 4 times square root of z times square root of w. And then the joint density function of z and w is defined as the root being plugged into the density function of x and y over the Jacobian determinant absolute value. And so we get a final result of this. So inside here, the square root z, square root w cancels out. So in this pair of brackets, we only have 4, and that cancels out with the denominator here. So eventually we have 1 over 2 times square root z times 1 over 2 square root w. Fifth question, prove or disprove that x squared and y squared are independent. Well, because The joint density function is the multiplication of a z function and w function, so that we can know that x squared and y squared, which are what z and w represent, so they're independent.